This is a GCSE physics presentation looking at pressure in gases. To get started, draw three boxes 5 centimeters by 5 centimeters in size. Inside each box, you need to draw the arrangement of particles in a solid, a liquid, and gas, and label the boxes accordingly. Pause the presentation, and when you're ready, restart to check how you got on. Well, the boxes in front of you now give you an idea of the kind of thing you should draw. Remember, in a solid, we're looking for a regular pattern. They do not have to line up into rows and columns. You can have them slightly off, but they must always be in a regular pattern. They must always be tightly packed together because they're not allowed to move. They can only vibrate around a fixed point. In liquids, the particles are more spread out, but they're still quite closely packed. They can move past each other, so there should be some spaces in between, but the majority, well over half of the particles, should be touching other particles. And in gases, of course, particles will spread out completely separate from each other, moving in random directions, and there should be gaps between them. Remember, the number of particles in the solid and liquid and gas will be the same. They're just more spread out, hence in the little box we can only see a small number of the gas particles, but because we can compact them so much, we see a large number of the solid. In this lesson, we're going to look through the motion of particles in gases. We're going to look at the effects of changing temperature in gases when volume is fixed. And we're going to explain how the motion of molecules in a gas is related to its temperature and its pressure, and the relationship between the temperature of a gas and its pressure at a constant volume. So gas particles. Remember, gas is an example of a fluid, the other fluid, of course, being liquids. And in a gas, particles are moving in a constant random motion. The temperature of the gas is related to the average kinetic energy of the particles. What happens when particles are heated? Well, when particles are heated, you should know the particles move faster. So the higher the temperature of a particular substance, the higher the average kinetic energy that the particles in that substance have. And the higher the kinetic energy, the faster the particles are moving. Well, what happens to particles at a temperature of absolute zero? Well, at absolute zero, particles have no internal kinetic energy, and so they do not move or vibrate in any way. In terms of pressure, when you have a particle hitting a surface, that particle exerts a force on that particular area of that surface that it's made contact with. That force on that particular area is known as a pressure. You can change the magnitude of the force, will obviously change the pressure, but also if you change the area that that force is applied over, you will also change the pressure. So if you look on the right hand side, you've got object A and object B. If both objects are hit with the same amount of force, which one will go further into the wood, A or B, and why? Well, I hope it's obvious that object A would go into the wood more, but the reason it would go into more is because the area that's in contact with the wood is much smaller in A. Therefore, when that force is applied, you have a much higher pressure. So remember, pressure is dependent on area and force. And that's where we derive the calculation from. We got a calculation in which pressure is equal to the force at normal to that surface. Remember, that means perpendicular or at 90 degrees. And of course, we have to divide that by the area of the surface, because the bigger the area, the lower the pressure. You do need to memorize that equation for the AQA specification. You also need to be able to rearrange equations. Remember, when you're rearranging equations, you should be using a Smurf, simple method for understanding a rearranging formula, which is the little triangle shaped structure on the right hand side. And what you should be able to do is if you put your finger over A, then we get F divided by P. If we put over P, it's F divided by A. And if we want to calculate F, it's P multiplied by A. When you have gases, the temperature of the gas is a measure of the average kinetic energy that the particles in a substance have. When we say heat, we're talking about all the energy in the substance. The more particles a substance has, the more energy is needed to increase its temperature. If you have a balloon stored at room temperature and that balloon is heated up, what would happen to the temperature of the particles in the balloon? Well, you should know that as we're providing energy, we are increasing the temperature. What will happen to the volume of the balloon? Well, if we increase the temperature, we've already said that an increase in temperature provides more heat energy. And if it's more heat energy, the particles are going to move faster. If they're moving faster, they're going to hit the outside of the balloon with more force, and they're going to hit more often. Therefore, the balloon is going to have an increase in pressure, and it means the volume is going to get bigger. We also have examples of where we can do exactly the same thing about heating up particles inside a container, but this time the volume is fixed. The volume is constant. Unlike the balloon, there's no space for expansion. And a good example of that is an aerosol can, which is filled with gas. If you get an aerosol can and heat it up, why is that dangerous? Well, the reason that's dangerous is quite simple. The volume inside the can is fixed. There's no room for the volume to get any bigger. And if you heat the particles up, they collide more often and with more force against the wall of the internal wall of the aerosol. And if they hit with enough force, and if they hit it often enough, they increase the pressure high enough that it actually means the can's integrity no longer is held together, and essentially the can explodes. So when we have particles inside a container of gas, and we have a constant temperature, when we squeeze the container, we're decreasing the volume. Because we are decreasing the volume, the particles inside are being pushed closer together. And because they're being pushed closer together, they start hitting the wall of the container more often. And as a consequence, we have an increased pressure, which is why it's an empty bottle you can squish very easily at the start, but eventually you get to the point where you're going to find it very difficult to get enough force to squish the bottle any further, even though there appears to be empty space inside it. Well, why is an empty bottle easier to crush than a full one? Well, it basically comes down to a full bottle is normally filled with liquid, and liquid particles are more closer together than gas particles. So when you have a gas in there, you have a lot of space between the particles, therefore you have lower pressure, therefore it takes less force or external pressure to squish the bottle. To finish off, you have to talk continuously about the material covered in this session for 2 minutes without stopping. At first repetition, pause a mistake, you gotta start again, and you of course can talk to a family member, pet, mirror, or yourself about everything that's been covered.